So let's look at conic sections in general. A conic section, and there are 4 of them, are the way that a curve is intersected by a plane and a double cone. So depending on how you slice this plane through the double cone, you get one of the 4 conic sections. So the first one here being a circle, the second one being a parabola, the third one being an ellipse, and the fourth one being a hyperbola. So we're going to look at all 4 of them together collectively in some of the ways that they are similar. In the future lessons, then we'll look at how do the conic sections, like what are the specific details for each one. But in general, when we look at an equation, we'll want to be able to pick out, okay, how do I know that's a circle? How do I know that's an ellipse? How do I know it's a parabola? So forth, okay? Now, I will say a parabola is something that you've heard before because in Algebra 1, we start looking at parabolas. We look at the parabolas that are functions, but we don't look at the parabolas that are not functions. And so here in Algebra 2, we're going to bring in that piece, that component. If there are some parabolas that we haven't looked at before, and the reason we haven't looked at them is because they weren't functions. So let's go ahead and look then at problem number 1. And we're told it's a circle, and we're asked what is the graph of x squared plus y squared equals 25. What are the lines of symmetry? What are the domain and range? So please understand that later on in future lessons, you're going to be asked to graph, and you're going to be asked to know that that equation is a circle. I don't think that's the case at this point, that you need to know that, okay? I think for this particular problem, I'm going to go old school, and I'm just going to make a little t-table for x's and y's, and I'm going to then plot some points. I'm going to see what this graph looks like, okay? So let's put in some positives, some negatives, and 0, of course. So I'm going to put -2. I'm going to put 0, and then I'm also going to put x value of 2. So let's think about what happens when I put in an x value of 2, okay? So I've got x squared plus y squared equals 25. So I've got -2 squared plus y squared equals 25. It's not going to come out super nice, but let's just look. I've got -2 squared, which is 4, right? So if I subtract that on the other side, I've got y squared equals 21. So I've got the square root of 21. Actually, I've got the positive or the negative square root of 21. Now the negative and positive square root of 21, those are a little bit bigger than 4. And you can type that in your calculator and get an approximate value. So 4 point some stuff, okay? So it's a little bit bigger than 4, but it's about 4, okay? No worries, glad you could join us. All right, now, what does that look like on my graph? Well, let's just draw ourselves a graph here. Again, forgive my Sonic gift card here is going to be my straight edge today. And I don't know about you, I'm just one of those, when I'm drawing a graph, I kind of want it to be at least precise. And it's a good question, why did I put -2 twice? Because the y values here could be 4 and some change, or -4 and some change. All right. So we've got to be real careful that we include both of them. All right, So we can graph these, right? -2 and +4 and some change, right? Then I've got -2 and -4 and some change. I actually get both points. And I get questions on that. Why do I need both of them? Well, you do, because when you take the square root of 21, you've got to consider that it could be positive square root of 21 or it could be negative square root of 21. All right, let's put in 0. This time I've got 0 squared plus plus y squared equals 25. You can see that 0 is going to have a y value of 5 or -5. So we'll plot those. You're getting this curve that's not a function. We haven't had that before, right? Up until now, everything you've been asked to graph is a function. So when you put in an x, you got a single y. And that's different for conic sections. So now we know what we've got, the kind of shape around this circle here. And so I can easily see that my radius is going to be 5. So that's my furthest point, right? So you can draw, and if I had a compass, we could get a really exact drawing, but I don't. That's okay. So my circle is going to look a little bit elongated, but it actually, if I were to graph it exactly, I would get a circle, a perfect circle. So there we go. Okay, now look at the equation. Look at the equation. And let's see, how did I know the radius was 5? What about the equation told me the radius was 5? Go ahead and tell me in the chat there. Beautiful. The constant. Yes. Right. The constant tells me that the radius is 5. Another thing that I want you to see is that this circle is centered at the origin. Now, when we do a lesson coming up where we're just looking at circles, we're going to move that center around. But for now, when we're just looking at these conic sections, we are just going to have them centered at the origin. Now, look at what the questions we're being asked now is. What are the lines of symmetry? Now, remember, my graph is not perfect. If I wanted it perfect, I should have drawn it with a compass. But where could I cut this graph so that I get 2 equal halves? What lines could I cut this graph at? Any diameter. Good. Okay, I like that. You're coming from more of a geometry mindset, and I kind of want an equation of a line. Come from an algebra mindset. There we go. The x or the y-axis. And we could even put equations for the x and the y-axis. We could say that the lines of symmetry are at x equals 0 and y equals 0. We really could cut it even further. We could go at the line y equals x, y equals -x. If we want to go even further, okay? Now, let's look at, now that we've got a graph, and there's a reason we graphed it first, let's talk domain range. What do the domain, what's the x values that it stays between? And you can say this in either, you could say this in interval notation, or we could say it in inequality. What would my domain be here? My x's have to stay between what 2 values? Yeah, it's got to stay between -5 and 5. So if you want to say it with inequalities, you could say it something like that. Okay. If you wanted to write it in intervals, Haley's jumping there. Good. Make sure you use the bracket so that you include those endpoints. I do have points at -5 and at 5. That's okay. Now my range is pretty boring for the circle because I get the same range just with a y. Very nice, very nice. Okay, now really remember, just for now, there's more details with circles. And remember, we're going to eventually start shifting those circles around in the coordinate plane. But for now, we want to be able to recognize the radius. We've talked about that being the square root of the constant. We want to be able to draw not a perfect graph, but a good sketch, get those endpoints right. And we want to be able to identify those lines of symmetry and the domain and the range. Okay, for today, that is enough. Future lessons coming, we will ask you to do more, of course. Close enough, right? Okay, friends, let's take a look then at the ellipse. For the second one, we're going to use a similar approach, okay? So for this one, I'm going to use that same approach with some positive x's, some negative x's, and then of course, 0. This one, I'm going to try to be wise with those values that I choose. And let me see if I can get my document camera to zoom in a little bit better. There we go. I'm going to move me down here so we can see a little bit better. All right, so let's plug in some x's and some y's. I don't get super fancy with these, although you can. Meaning I don't choose really complicated x's and y's, I just choose some. The more you do of these, the smarter you'll get about which x's to choose. And then of course, when we do the lesson that's only on ellipses, you'll be able to pick out more information based on what you're given. Okay, all right, let's plug these in for x and see what we get. I'm just going to come over here and do 9 times negative 2 squared plus 16y squared equals 144. Okay, negative 2 squared gives me 4, and 4 times 9, of course, is 36. We can subtract the 36, and that will give me 108. And then you can divide by 16. Again, this is not going to come out super, super pretty, but we'll get close. So I got 6 3/4, which means my y is about 2 point, I'm guesstimating there, 2.6, plus and minus, of course. Okay, so I've got about a 2.6 and a negative 2.6. That'll kind of give me an idea of where I'm at. Okay, let's plug in 0 next. So I've got 9 times 0 squared plus 16y squared equals 144. This one should be super easy. So I've got 16y squared equals, and then let's just go ahead and divide by the 16. So 144 divided by 16 should be 9. So at 0, we've got plus or minus 3. Yep. So I've got 3 and I've got negative 3. I'm going to write it like that. Okay, and then pretty easy to see that I'm going to get 2.6 and negative 2.6 there. All right, so let's take a look. Now remember, we're going to go back to our graph, not because of anything other than I just want to see the best shape that I can. And so let me flip my paper around here and get my straight edge. And draw I'm going to pan my document camera back out a little bit. There we go. Okay, so there's my axes. Let's plot our points and kind of get an idea of what this looks like. So I've got -2 and I've got 2.6 something, and I've got -2 and -2.6 something. I've got 3 and -3 at 0. And then I've got 2 and 2.6. Okay, so it looks like my heights of my parabola, I'm sorry, my ellipse are at 3. And I'm going to go ahead and fill in the other details just to save ourselves time. Now, hear me, you could plug in a lot more points and get a more and more accurate sketch. Okay. Now, our ellipse, while mine might look like a hexagon, an ellipse is more like a football shape. Okay, you've seen a football before, so you get that elongated shape. Now, how long it is versus how wide it is has to do with the equation. Okay, so I want you to notice that this is 4, and I want you to notice that this is 3. And look at the equation. Oops, sorry about that. My document camera is a little top heavy today. Look at the equation and tell me where I got the 3 and the 4 from. Where did I get 3 and 4 from in the equation? Ah, now you're picking up on Kelsey. Kelsey's seeing it. Yep. Right. Right, those coefficients dictate what we call the major and the minor axis. Remember, more details coming in future lessons. For today, that's what I want you to be able to know, is to pick out, make that connection between, hey, I know something's going to go on with 3, I know something's going to go on with 4 because of the coefficients I see in there. Okay, now that you have your graph, can you tell the domain and the range? Let's do that. What is the domain and the range? What is my domain here now that I have this graphed? Did all that work? Good. I'm going to add, we'll be real careful, Amira. I think you got it backwards on this one. I think you did the range. Yep, my domain is actually -4 to 4. And my range then has the -3s with it. Yep. Okay. Just watch the details on that. Great. Okay. Now, we've done a lot of good work there. So look at the difference. What's the difference between a circle and an ellipse? The one on the top is a circle. The one on the bottom is an ellipse. What's the difference? Yeah. It is those numbers. It is those numbers in front of the variables here. Now, I will caution you, this could be a circle. Okay, you can have coefficients in front of x squared and y squared and still be a circle. The difference is that when they're the same number, it's a circle. When they're a different number, it's an ellipse. Okay? Because notice in this one, you could easily just divide by 2, right? And you would get back to a similar format as this circle. Yeah. Okay, fabulous. Well done. Okay, so remember, we're staying very general with our ideas today. We are coming with lessons coming up in Unit 7 that are going to be more specific. You're going to be able to pinpoint the radius from the circle. You're going to be able to pinpoint the diameter, the center, the major minor axis. In ellipses, they have foci. Okay, you're going to be able to go through all of that. But today, we are about looking at the conics all together and being able to pick out which one's which. Okay, so look at this one. Now we know we're going to be dealing with the hyperbola because they told us. But what do you notice is different in the hyperbola equation? All of the equations are similar, but what's different in the hyperbola? You got it. It's the minus sign. Yeah, that big minus in between them changes a lot. Okay, so I'm going to share with you a method, and I'm going to do it very simple. I'm not going to get too many details, okay? Because sometimes with the hyperbola, it can get kind of weird trying to graph it because of the way it looks. So let me show you just a very simple way with this equation how we can graph the hyperbola and it will look the best that it can look, okay? So I'm drawing myself a set of axes here. And I'm going to go with a pencil next. And the reason I'm doing it with a pencil is because what I'm about to draw is not actually in the graph. It is just helping me set up the graph, okay? All right. So what I do, and I noticed the 9, and you can tell with all the conic sections we've been doing, there's a lot of perfect squares going on. Okay, so I know the 9 is important, which leads me to believe 3 is important. So I'm going to start at 0, 0, because I see these x's and y's are by themselves. I'm going to go 3 in each direction. So I went 3 to the right, 3 up, 3 to the left, 3 down. Okay, so I made those 3 points. And what I'm going to do is I'm going to kind of go ahead and make myself a box, a square, based on these points. So just making myself a square with those points. Okay. Okay, all I did was really just key in on the 9 and then the 3s being important. And then I'm going to take my straight edge and I'm going to make diagonals across my square that I've drawn here. And I'm going to go dash. Because remember, and I'm still doing it with pencil because they aren't really part of the graph. They're just helping me set up portions of the graph. So I'm just, like I said, using dashed line with a pencil. There we go. Okay, so I've made a box and then I drew the diagonals around it, right? Yeah, okay. So why did I do that? Well, because the parabola has a very unique shape. And so since I see the x squared come first, I know that I'm going to draw what looks like parabola branches. Okay, now follow me here. That would be a parabola shape, right? The pink, except it's on the side. Okay, and I get another one over here. And that's my hyperbola graph. Yep, right. Each branch of it might look like a parabola, but together they make a hyperbola. Why? Great question. Ask, why did I draw the diagonals? The diagonals are actually called asymptotes. And the hyperbola always has two of them. And it keeps my branches from just running wherever. They are guided by those asymptotes. So a very unique shape with the hyperbola. Asym, A-S-Y-M-T-O-P-E-S, asymptotes. So this gets really different, right? We get a totally different shape with that minus going on there. All right, can we tell the domain and the range? Very tricky. The box actually helps us see the domain a little bit better. So let's just deal with one side of this at a time. Look at this left side for its domain. What would the domain of this left side branch be? Well, tricky, isn't it? We're going to have to do it in two parts. So we'll say x is less than or equal to -3. Or what is the domain of this branch? X is greater than or equal to +3. Ooh, that's tricky. Okay, let's do the range then. This one you can do with either branch. You're going to get all real numbers. Yes. If you want to write that as an interval, you would say -infinity to +infinity. Again, going to get more details with the hyperbola when we do the hyperbola lesson, but I want you to be able to see the general shape. Someone asked me, how do I know if the branches go on the top and the bottom? If the y-squared came first, you would know the branches went on the top of the box and the bottom of the box. It's really a lot of fun if you get into the details of the conic sections, because then it's interesting to see how they all work together. All right. Let's see. I think I've got another one here. Look at the bottom. So let's see, and I do see your question about the difference between the hyperbola and the parabola. I will be glad to answer that in just a second. So this one says, what are the center and intercepts of this conic section? And then what are the domain and the range? So the center is where you need to visualize the box going on right here, right? You've got your box here and here, right? And the center of your box is going to be the center of your hyperbola. That's going to be at the origin, 0, 0. Now, the intercepts, that's where you touch the axes. So in this case, you've got X-intercepts. And they're at, and look at these, each of these go by 2. So your intercepts are at 2, 0 and -2, 0. That can be very deceiving, okay? If you're counting and try to count by ones, when you actually need to count by 2s on this graph. All right, then my domain with hyperbolas, remember, you're going to have to split them. So you're going to have to say that x is less than or equal to -2, and x is greater than or equal to 2. Do each branch separately, write the domains for those. And then very nice, the range here, again, all reals. Okay, now I'm going to answer the question about the hyperbola and the parabola. If you have any other questions, go ahead and put them in the chat there. So someone asked the difference. The hyperbola and the parabola, very similar, okay? If you remember from our days with Algebra 1 and a little bit of work in our last unit, the parabola only has one squared term. So you either have y equals something x squared Or we're going to bring in x equals something y squared, which in some case you would get this graph, right? Just one branch of the hyperbola, but it would be turned, would not be a function. So that's a way to tell the difference both in the graph as well as the equation. Okay, let's look at our last few here. Okay, so again here we're looking for what's the center, what are the intercepts, and then the domain and the range. Now this one obviously is an ellipse. So let's identify the center. All of our ones today have been centered at the origin. That just means in future lessons, you're going to start seeing them shifted around. It's going to complicate things a little bit, but not too much if you can identify the center. Okay. My x-intercepts, I have them at, let's see, we're going by 2. So 2, 4, I've got them at 6, 0, and negative 6, 0. I've got y-intercepts. Let's see, again, going by 2, 2, 4. So I've got a 0, 4, and 0, negative 4. Now those intercepts are going to be very key to your domain and the range. I mean, they're just going to really translate into your domain and range. So your domain here would be negative 6 to 6, and I need brackets if I'm going to do that interval notation there. If you want to write it with inequalities, you of course could write it like that. Let me move my video out of the way. Then if you want to do the range, you would go from negative 4 to 4. Okay. So good work there. I mean, we're really putting the pieces and the parts together. I'm loving that you're seeing how they're connected. And there's a much better drawn ellipse than the one I did, but you get the idea, right? You get that football shape. Not as pointy on the ends as a football, but still got the nice rounded shape, a little bit longer. But realize you could be a little taller than Y2. You could have a vertically elongated ellipse as well. All right, just one more to go, friends. That's our last one. What are the center and intercepts for this conic section? So my center here, again, like all the ones in this unit, is 0, 0. I'm sorry, in this lesson, not this unit. My intercepts, looks like I have y-intercepts this time because notice my branches of the hyperbola open up and down, right? So my y-intercepts are at 0, 1 and 0, negative 1. This one's a little different now because my branches open top and bottom. So my domain is now all reals. And my range is the one I have to break apart. So I'm going to break my range from the bottom to my first branch. So I'm going negative, I'm going to go y is less than or equal to negative 1, or y is greater than or equal to 1.